Okay, here's another dimensional analysis or factor label practice problem. And again, we have to know how to do these in order to eventually work our way up into a multi-step stoichiometric conversion problem. All right, the problem asks for how many grams are in 4.63 times 10 to the 24th molecules of carbon tetrachloride, CCl4. All right, if it's asking for grams, we know we're going to have to refer to the periodic table. And when you look at the periodic table, for our practice problems, I'm telling students just to round the mass up, and we'll assume it's that isotope of that element that we're talking about. So I know the mass of carbon is 12, and chlorine is 35, all right? So that's gonna come in handy in just a minute. So I'm gonna just put masses up here. But you will need to look at your periodic table to do these problems. All right. First step, you always write the number and unit being given. So this is what's given right there. 4.63 times 10 to the 24th molecules. If you see the word molecules, it just means that you're dealing with a compound and not just an element. But automatically, if you see the word particles, molecules, or atoms, you need to think about Avogadro's number, okay? So we have molecules of CCl4. Whatever unit you start with, that unit must go on the bottom of the conversion factor. So I'm going to put molecules on the bottom. All right? So if you have to kind of step back and say, okay, what do I know about molecules, and I'm trying to get to grams. Can I go directly from molecules to grams? I told the class to memorize that 1 mole of anything is equal to the atomic mass of that thing in grams, and it's also equal to Avogadro's number of atoms or molecules. That you just have to commit to memory, okay? So I know that Avogadro's number of molecules, 10.02 times 10 to the 23rd, that must be equal to the total mass of whatever compound you're speaking about. Carbon tetrachloride has a total mass of, it has 12 for one carbon, 35 for chlorine, but we got 4 chlorines. So we've got to add all these individual numbers up to get a total mass. So if I add 4 times 35 plus 12, I get 152 grams for the mass of carbon tetrachloride. So where do I write that? I'm going to erase this because it's kind of crowding out stuff. I'm going to put 152 grams on top. Okay. Now I like to go back and just double check. I have to double check my work too. So there's nothing wrong with doing that. So I always go back and double check that you don't have any errors, right? So if I go back and I double check this conversion factor, all right, I have to say, is that true? Is that a true statement? All right, are there that many molecules or atoms in the total mass of anything? Yes, because that was just the fact that I had to learn, right? So I know that any compound's mass in total grams, it has that many molecules in it. So that would be correct. Can molecules cancel out with each other? Yes, and it would leave me with grams. And the problem says how many grams are in that many molecules. So now I'm ready to just crunch the numbers. Be careful, I would rewrite this again and put 4.63 times 10 to the 24th times 152 over, and we know that number is over the number 1, so I don't really need to write it by 1, but 6.02 times 10 to the 23rd would be in the denominator. I like to put parentheses around everything just to make sure my calculator, all the numbers are put in correctly and there's not some weird order of operations that kicks in and gives me the wrong number or answer. So put parentheses, and here's how I literally key it into the calculator. I would suggest a TI-30XA. They're relatively cheap and they're easy to use. So a TI-30XA is what I'm using. I have an EE button to do scientific notation numbers. So I'm going to say 4.63 EE24 times 152 equals, hit equals, divided by, and again, always just open and close parentheses. Open parentheses, 6.02 EE24 23, close parentheses, equals. Now, if you didn't get all that the first time, rewind this video and go back through the process again on the video, all right? But I'm getting, and I always do it 2 or 3 times just to make sure I didn't key something in, and make a mistake. I'm getting 1,169.036545. So I'm getting 1,169 grams. So my answer, final answer, would be 1,169 grams of CCl. Notice how I put the entire unit there, all right? So don't get sloppy, don't get lazy, put the unit and put the name of the compound, all right? And that is how we do a factor label, otherwise called dimensional analysis problem, that's leading up to stoichiometry, because now we're dealing with ratios of chemicals, all right? Stoichiometry, it may be wordy, it may be tedious, but once you get the knack of it, it's not that difficult, really. So we started by writing down the given, and then you're going to multiply by some conversion factor where you can put in the denominator whatever the unit of the given is. It will go in the bottom on the denominator part of the first conversion factor. And then sometimes you can go directly in from one unit to the next, and it can be a one-step conversion, right? So this one, it's not real lengthy, but you just got to make sure that you put all the numbers in the right places. If you show all your work, then you'll avoid any kind of careless error.